So in part 3 of this lecture, I'd like to talk a little bit about conversions. When units are not consistent, you may need to convert to appropriate ones. And the inside cover of your book has an extensive list of conversion factors. Units can be treated like algebraic quantities that can cancel each other. So for example, if I wanted to convert 15 inches into centimeters, I would need a conversion factor. 2.54 centimeters is the same as 1 inch. And if on the left-hand side of this equation I multiply it out, then the unit inches on the top and on the bottom would cancel out, and I'd end up with only units centimeters on the other side. So let's look at an example. How many meters are in 12 feet? Well, we'll start out, we know that 1 inch is equal to 2.54 centimeters. Now, if I divide both sides by 2.54 centimeters, I end up with 1 inch over 2.54 centimeters is equal to 1. Now, 1's an important number. I can multiply anything by 1 and it doesn't change it. I get the exact same thing back. And the same is true here. So converting is really about multiplying by the appropriate value of 1. So another value of 1 we might need is in 12 inches is equal to 1 foot. So 12 inches over 1 foot is equal to 1. So how do I use that? Well, the conversion, 12 feet. All right, so first thing I'd multiply by 12 inches over 1 foot. That's equal to 1, so it doesn't change it, but the feet cancel out, and I'm left with the unit of inches. Well, I want to get rid of inches, so I can multiply by another appropriate value of 1, 2.54 centimeters over 1 inch. The inches cancel out, and I end up with centimeters. But I wanted meters, so 1 meter is 100 centimeters. The centimeters cancel out, and all I'm left with then is meters, and so I get 3.7 meters. Now there's lots of different places we can find conversion factors. For example, just on this aluminum foil, 37.5 square feet. And if I look down below, that's the same as 3.48 square meters. Now another thing we need to talk about today is estimations. Estimating can yield some approximate answers. Maybe I don't need to know the exact answer of something. Maybe it's difficult, maybe it's impossible because of the math or limited information. But an estimate can serve as a partial check for an exact calculation. Another need for this is an order of magnitude, because perhaps all I really need to know is an order of magnitude. If I'm ordering length of cable to restring the Golden Gate Bridge, I might not need to know I need 300,000 feet or maybe 300,121.238 feet. I really don't need to know that. I need an order of magnitude. So an order of magnitude just means I'm within a power of 10 of an exact answer. All right, for example, let's look at a problem. What's the area of a slice of Earth at the equator? Well, I don't need to know within a square inch what that might be. I just need an estimate. So we'll take a look, and we know the Earth is about 24,000 miles around at the equator. It's not exact, it's an estimate, but we can use that. We know that the circumference is 2 pi r, so the radius is circumference over 2 pi, so that gives us the radius, and then we know the area is pi r squared. So we plug in the radius, so that would be pi c squared over 2 pi quantity squared. Cancel some things out, it's c squared over 4 pi. All right, so what is c squared? Well, let's see. I need to square 24,000 miles. Well, 24 squared is 625. That's close to 600. So let's just call it 600, and then I have 2 sets of 3 zeros after that, so that would be 6 times 10 to the 8th on the top, and of course 4 is 4 pi. Well, it's approximately 3. So 6 divided by 3 is 2, 2/4 is a half, so I end up with the area is about 5 times 10 to the 7th square miles. The exact answer is 4.8 times 10 to the 7th square miles. So we were able to use an order of magnitude calculation. We just rounded things. We didn't worry about 3.14, just 3. We threw things and we got an order of magnitude calculation. An order of magnitude calculation, or an estimate, is not meant to be an exact number. 1 or 2 significant figures probably just 1, and an appropriate power of 10, just to get an idea of what the answer would be. So another problem that you might solve, an order of magnitude problem, is how many breaths do we take in our lifetime? Well, you're going to need to make some estimates on what's the average rate that somebody breathes during the day, or how many breaths a minute does someone take? How old does someone live on average? There's lots of things that you'll estimate and you'll get an answer. I'm not going to work that out here. I want you to work that out in the problems after this video. So, to review, we talked about measurements. We've talked about significant figures and how to keep significant figures when we add, subtract, or multiply. We briefly discussed the structure of matter. We talked about dimensional analysis. And we've talked about units and estimation. So that's it for today's lecture. Finish these problems, work on the homework, and we will talk to you in class.